here we are discussing about the lithography method. We are defining the photolithography method. That there are different processes to develop a film or to develop a devices by using the photolithography. And here we are discussing about the one of the method, which is the spin coating, to develop the thin film. Another method is the spray development also. During the spin development, wafers are spun and developers is poured onto the rotating wafer, as we discussed. In the spray development, the developer is sprayed rather than the poured. The particular resist is sprayed on the wafer using the nozzles that produce a fine spray on the wafer. So by using two methods, we can prepare the resist, either spin development or by using the spray development. The next step is the hard baking. In the hard baking, the resist should be hardened on the surface. So it is heated at temperature 120 degrees centigrade to the 150 degrees centigrade, so that it will hold out the harsh environment of the etching, and the pattern will be hard on the wafer, on the surface or the substrate. Next step is the etching. Etching basically is a process where we use the wet chemicals to etch out the surface or to remove the undesired area. So etching consists of two types, in which one we use the liquids, wet where we use the acids, and another is the dry etching where we use the bombardment of ions to expose the material. So etching may be done by two types, first by the wet or the dry, wet by acid and dry by the ion bombardment. The photoresist will resist the etching and protects the material covered by the resist. That's why the etching is very important, and this etching is complete, the resist is stripped, leaving the desired pattern on the wafer. What is stripping? After the image developed on the wafer, that has been etched, the remaining photoresist from the surface of the wafer, that should be removed on the surface of the wafer. Therefore, the two classes of stripping techniques is used. First is the wet stripping and second is the dry stripping. In the wet stripping, we use the acetone, and acetone tends to leave the residues on the wafer. Most commercial organic stripper are the phenol based, and this is diagram of the stripping. And this right hand side diagram will show the sample fabrication of the photolithography, the sample which is prepared by the photolithography. These are the methods to develop the pattern on the wafer, on the substrate, by using the photolithography. What are the applications of the photolithography? As we discussed, that the technology demand, it is mostly used for IC designing processes, and other applications is used in the printing the electronic boards, electronic gadgets, electronic devices, and it is used for the name plates and the printer plates. They are the basic use of the photolithography. Once a mask prepared, then the mass number of devices can be prepared by using that mask and using the steps as we discussed. The next important lithography method is electron beam lithography. Electron beam lithography, as name indicates, that we require the electron beam that can be focused for a nanometer diagram, so that we can develop the nano devices by using the electron beam lithography. So what is this electron beam lithography? Is specialized technique for creating extremely fine patterns by using exposure of the electron beam. It is derived from the scanning electron microscope, and electron beams can be focused to a few nanometers in the diagram. Electron beam lithography idea behind that is it is identical to the optical lithography. The substrate which are using is coated with the thin layer of the resist, which is chemically changed under the exposed to the electron beam. We take the wafer, photoresist is the layer of resist will be developed. In the previous we use the photoresist, here we use the electron resist. Layer is developed on the surface of the wafer and this exposed with the electron beam. So the exposure and unexposed area can be dissolved in the specific solvent. The process is same. We prepare the photoresist on the wafer and then by electron beam we create a small devices on it on the wafer. The electron beam lithography is the most powerful tool for the fabrication of the small devices of the size 3 nanometer to 5 nanometer. The electronic devices can be directly prepared by the electron beam lithography method. Electron beam lithography method nanoscale design is done on the computer by direct electron beam and the pattern is writing on the chip using the high precise mechanical devices. The goal of the electron beam lithography is to write the high accurate and reliable pattern on the wafer or just to develop a high accurate and reliable pattern writing. And it is highly focused electron beam is exposed to the resist material that modify the solubility of the resist for the development. This electron beam when fall upon a resist area, then it will modify the solubility of the resist which will be used in the development of the devices. And it allows the accuracy down to a small as area of the 10 power minus 9 meter, means 10 nanometer dimensions size devices we can prepare by using this method. This is the electron beam lithography method. Here we see in the right hand diagram right side that electron beam system is normally referred to as the column as shown in the figure and typically consists of the following component. Number 1 is the electron source. What electron source we use? We use the electronic beam. Electrons may be emitted from a conducting material either by heating or applying the electric field. As we see in the diagram, the topmost here we are having the electron source, and electron source may be by using the heating or maybe using the electric field by applying the electric field. The next is stimulator, that is the special type of lens that is kept after the electron beam fall upon it and alignment of the which is used for the alignment of the electron beam. This lens may be either electrostatic or magnetic, which consists of 4 or more poles. What are these this lens is used for the alignment of the electron beam towards the wafer. And next is the electron lens. Electron lenses can be made only to cover, not diverge electron beam, so that it can be focused towards the wafer. The focus either by the electrostatic force or by the electromagnetic force, and it will go towards the wafer. So electron lenses are used for divergence of not divergence of the electrons, direct flow of the electrons on the wafer. The electron beam lithography, basically it consists of different columns and it is just similar to the scanning electron microscope, and it consists of the 4 component. First is the aperture. These lenses consist of the 4. First is the aperture. Aperture are small holes. Here we see on the right hand side we use the aperture which through which the beam passes on its way down the column. the narrow beam can be passed towards the wafer. So we use the aperture, which is of the small holes. There are other several types of the apertures. A blanking aperture is used to turn the beam on or off. Sometimes we direct send the beam, or sometimes we send the beam in the form of the pulse. So these apertures are used to send the on and off system. And these beam limiting apertures has a two effects. Number one, where it sets the beam converge angle through which the electrons can pass through the system, controlling the effect of the lens and aberration and thus its resolution, so that it can fall upon the wafer. After lenses, we have the blanking plates. These blanking plates are used to modify the E beam. How we use these modify? This is very simple electrostatic deflector which pass the beam towards the wafer. One or both of the plates are connected to the amplifier with a fast response time, and this E beam is modified by the electrostatic deflector. What are the advantages of electron beam lithography? So in the previous, we just having in this diagram, the beam come from the electronic source, it pass from the lenses, it pass from the divergence, is pass from the blanking plates, finally it fall upon the wafers, and the pattern is developed on the wafer. In this manner we can develop the wafer. In the previous, in the photolithography techniques, we use the masking techniques, but here in this E beam lithography, we are direct writing on the wafer. There we use the mask to develop the electronic devices. Here in the electronic beam, we use the electron beam to develop the pattern on the wafer. The nano patterns can be developed on the wafer by using the electron beam. What are the advantages of the electron beam lithography? By using this, we can print the complex patterns directly on the wafer. We don't require the masks to develop the pattern on the wafer. Eliminates the diffraction problems. Resolution up to the 20 nanometer, which is very less in the photolithography method, which is 50 nanometer. This is the most flexible techniques, and most of the devices prepared by using the E-beam lithography. What are the disadvantages of electron beam lithography? This is very slower than the optical lithography techniques. It takes time to prepare the devices. Approximately 5 wafers per hour will be prepared at less than 0.1 micron resolution. This is very expensive and complicated. This is both forward scattering and the backward scattering, and it uses the secondary electrons. Electrons beam is of the high energy. So this electron beam lithography having the disadvantages. What are the application of the electron beam lithography? As we see in the diagram, a pattern is formed by using the electron beam lithography. The primary purpose of the electron beam lithography are just to prepare a very high resolution lithography. Very high resolution devices can be prepared by using the electron beam lithography. And second is the fabrication of masking, which we will use in the photolithography method. So electron beam lithography is used to prepare the electronic devices and to prepare the masks. Next is the nanolithography. In the nanolithography, which used to develop the nano devices. By using nanolithography, we fabricate the nano devices. Basically, nanolithography concerned with the study and application of the nanometer scale structures that are most commonly used in our electronic gadgets. The nanolithography again comes from the Greek word which comes from the nano, it means small, and graph, litho means stone, and graphene to write. Then it means that we are writing tiny writing on stone. We are preparing a tiny devices by using the nanolithography. So, nanolithography most commonly used development of the nano devices, or we can say nano electronic devices. Nanolithography is used during the nano fabrication like the semiconductor integrated circuits. These circuits are used for the MEMS and in other applications, and this is used for other scientific purposes and the electronic gadget purposes. This method is different to nanolithography techniques like X-ray lithography, atomic force microscope, nanolithography, soft lithography, nano imprinting lithography, and dip pen lithography. They are the basic methods in which we develop the devices, but for the nano devices we use the nanolithography. Next method is the X-ray lithography. What is X-ray lithography? In the X-ray lithography we develop the film by using the X-rays. The X-rays which is having the wavelength of 0.4 nanometer to 0.5 nanometer, and it represent another radiation source for the high resolution designing production of the polymer resist material on the polymeric resistance material. And X-ray lithography was first demonstrated to obtain the high resolution designing using the X-ray proximity printing by the scientist. And this X-ray lithography can be extended optical resolution up to the 15 nanometer by using the X-ray source. What are the essential elements in the X-ray lithography? Like the photolithography, here in the photolithography we are using the UV light, in the X-ray lithography we are using the X-rays. So, mask is required in this X-ray lithography, a mask which consists of pattern which is made with an X-ray absorbing material on the thin X-ray transparent membrane. X-ray source of sufficient brightness so that we can prepare and we can expose by the X-rays, and X-ray sensitive resist material, and we develop the pattern. The X-ray illuminate a mask placed on the proximity of the resist coated wafer. First we take the wafer, then we prepare a film or thin film by using the photoresist, by using the spinning and the spray pyrolysis. After that the mask is used to prepare the devices, and X-rays fall upon by using this light, and the X-rays are typically from the synchrotron radiation sources which allowing the rapid exposure on the material, and in this manner by using the X-rays we prepare the light. The X-ray lithography is exposed because of the expense of the operating a synchrotron. The actual operating expenses without considering the initial investment of the lens of millions of dollars, we use the different forms. So, we use the molding. Molding is used for the development of the devices in the X-ray lithography steps. There are the different steps. First is the irradiation by the light, after that development, then electroforming, then module insert in the process, after that module fitting on the wafer, then module releasing after exposure of the light, then we can prepare a particular devices. So, we will discuss this method in detail. What are the advantages of X-ray lithography? We use the short wavelength, approximately 0.4 to 4 nanometer, no diffraction effect here in the X-ray lithography. It is very simple to use, molds are used, no lenses can be used in this method. faster than electron beam lithography. Uniform refraction patterns is used in this method, and it is a high resolution for a small feature size devices. What are the disadvantages of the X-ray lithography? In the X-ray lithography, we use primarily the nanolithography, and the 15 nanometer optical resolution we can get in this X-ray lithography utilize short wavelength of the 1 nanometer. It requires no lenses, and it allows a small feature size development devices. Thank you very much.